Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, lesson 9, arc length and areas of sectors. Okay, so before we talk about that, what's the difference between an arc length and an arc measure? Okay, so keep that in mind. They're different things. And areas of a sector. Well, we don't know what a sector is yet, but after today we will. Classwork example 1. What is the length of the arc of degree that measures 60 degrees in a circle of radius 10 centimeters? Okay. Well, let's explain this. If I took a circle and drew or took a string, if you will, and went around it. So I put a piece of string here and I had or even if you had like a hula hoop and you cut it and then flattened it out. Well, what is the distance around a circle? The distance around the circle is 10 circumference. So we know how to find circumference of a circle. The circumference of a circle equals 2 pi r, or the circumference equals pi times the diameter, depending on whether we know the radius or the diameter, which formula we use, okay? All right, so we know the circumference, the distance all the way around, but now I only have this much of the circle. All right, so I'm going to explain this to you rather than just giving you the answer. So think about it this way. If we had a central angle like so, okay, so since the radius that's cutting through the center of this is 10, both of these red segments I just drew are length 10 because all radii are congruent. Okay, well, we've created a central angle, and in prior lessons, that tells us that this angle is equal to the angle or the measure of the intercepted arc. So this is 60 degrees. This is a 60-degree angle right here. Well, how many degrees are in a circle if I go all the way around? The whole thing is 360 degrees. So I look at it as a ratio of the distance the arc is with respect to the whole rotation of the circle. So think of a circle as 360 degrees. We've gone 60 degrees around. So the length of an arc with a degree measure of 60 degrees in a circle with radius 10 is, what we do is, we say arc length equals, and it's a portion of the circumference. So this is a fraction, some fraction, a portion of the circumference where B is 360. So I'll just change that. So some A degree measure over 360 degrees times pi, 2 pi r. Ooh. Okay, since we know the radius, circumference times circumference, arc length is the angle divided by 360 times circumference, which is, I'll draw it like this for starters. And that simplifies to the angle measure over 360 degrees times 2 pi r. Okay? And then if I continue with this, then I now put in my angle measure 60 degrees over 360 degrees times 2 pi, and the radius is 10. Okay? So this 0 will cancel this 0. 6 will go into 36 6 times. So this simplifies to 1/6, and 2 times 10 is 20. 20 pi. Or we could write that as 20 over 6 pi. Reduce it to 10 over 3 pi. Okay? And if it doesn't say to simplify it or round to so many decimals, leave it in pi form. What is the length of the arc of degree that has a measure of 60 degrees in a circle of radius 10 centimeters? And the answer is 10 pi over 3 centimeters. Now keep in mind that since distance is length, it's one dimensional. It's not centimeters squared. That'd be area. Centimeters cubed would be volume. This is just 10/3 pi centimeters. Okay. Okay, part B says, given the concentric circles, what that just means is that you have multiple circles with different radius with the same center. That's all that means. So the center is A. So think of a target. A is the center. This is a circle with center A with a radius of 10. This is a circle with center A with a radius of 10 plus 10 or 20. And D way out here is a circle centered at A with a radius of 30. They're all 60-degree central angles here. So that means this arc right here from D down to here is 60 degrees. So it says, given the concentric circles with center A and with the measure of angle A 60 degrees, calculate the arc length intercepted by angle A on each circle. So now it's just different radii. So the arc length, and I will just say AL for short, equals 60 over 360 times 2 pi, the radius, 10. So that would be this red circle here. Whoops. How about I just do it this way? I will color code these circles as I'm going. Oh, wow, cool. Okay, so let's change that to line color red and no fill. Okay. All right. Okay, so I just did it in different colors, and that's how I'm going to do this in different colors. So I'm just going to write the arc length of the blue circle now equals, it's still 60 degrees for my central angle, divided by 360 times 2 pi. And now the radius is 10 plus 10 or 20. Okay, and then we're going to, let's just move these over, and then I'll do the green one. So arc length equals 60 divided by 360 times 2 pi r, and now r is 10 plus 10 plus 10, which is 30. So the arc length of this is going to reduce to 1/6 times 20 pi. This one will reduce to 1/6 times 40 pi, and this one will simplify to 1/6 times 60 pi. Now, when I simplify these, I get 20/6, which is 10/3 pi. This one will be 40/6, which is 20/3 pi. And finally, 60/6 is simply 10 pi. Okay, part C, it says an arc length of degree measure 60 degrees has an arc length of 5 pi centimeters. What is the radius of the circle in which the arc sits? Okay, so this is a great example of write the formula every single time before you try solving it, and the pieces fall into place. So I tell my students, write the formula, step 1. So arc length equals the central angle, let's call it theta, divided by 360 times 2 pi r, the radius. So then I substitute in my givens. Okay, an arc, again, of degree measure 60. So when I substitute in my given, that's going to change theta to 60 over 360. Okay, has an arc length of 5 pi. Well, where does that go? Over here. So when you do this, we plug this in and we get 2 pi r over here. And it says, what is the radius? So I want to move everything over to the other side. So before I do that though, whoops, I am going to, let's get this out of the way, just for now. Let's just keep working in a downward direction here. So then this would become 5 pi equals, This cancels. 6 over 36 is 1/6. So 1 times 2 pi r. So this would be 2 pi r over 6. So if I want to get rid of 2 pi and 6 and it's times r, I want to solve for r, then I multiply both sides by the reciprocal of this. And that would be 6 divided by 2 pi. And if I multiply, think of that as over 1, and I multiply this side by 6 over 2 pi, here's what happens. 2 pi and 2 pi cancel, 6 and 6 cancel, leaving me with r. Pi cancels pi. 6 divided by 2 is 3. 3 times 5 is 15. So my answer is 15, and notice the unit of measurement. So my answer should say that. Let's move this over a little and put cm in here. So the radius is 15 centimeters. Okay? And that's why it's important to write a formula, substitute in the given, simplify, and solve. Okay, part D says to give a general formula for the length of an arc of degree measure x degrees on a circle of radius r. Okay, so arc length equals x degrees over 360 degrees times 2 pi radius r. So there's the formula. X over 360 times 2 pi r, and a lot of times you'll see it this way in books. It's just the fraction of the central angle that intercepts the arc divided by 360. And there you have it. Okay, page 2, part E says, is the length of an arc intercepted by an angle proportional to the radius, and explain. Okay. Well, here we go. So the answer is yes. The arc length is a constant 2 pi times x over 360 times the radius when x is a constant angle measure. So it is proportional to the radius of an arc intercepted by an angle. Okay. So before I go any further, I want to discuss what a radian is, because down here we're going to get to it. See what B says down here? What is the radian measure of the center of the angle, of the central angle? So let's take a break here from the lesson and explain what radians are. Okay, so you ready to learn what a radian is? Okay, here we go. So if I take a circle like this, okay. Actually, let me do it center. Let me put a center in first. Let me put the center right there, and then I'll draw a circle about that center. Like so. So here is a circle. All right, so then what I'm going to do is I'm going to draw a radius like this. Okay, and that is a radius r. If I take that same radius r and rotate it so it's the same length, so how am I going to do this? Watch this. Okay, so I'm going to now draw a circle, and let me just make it red. And then this is just for construction purposes, a circle, and I'll do it red and very thin. Okay, so if, what did it do? Circle, red. And I want it thinner, like that. Okay, so if I draw a circle here with a radius going out to the other end, these are overlapping circles right here, and so therefore they share this common radius. All right, so I'm just doing that to show you that now if I take and draw a vertical line from this point here straight up 90 degrees, then I have this red line, which is a length of r, because it's the same length as this, and it's 90 degrees. Okay. Now picture this thing being like, I don't know, a stick or something, or a piece of metal, and it melts onto this sphere or this circle. And what it's going to do then is going to create an arc the same length. So I would assume that if this rotated over, it would be approximately end pointed right there. That would be the end point. So if I put my compass right on there and open it up to the radius and drop the arc to here, okay. Now I have a radius length of an arc. Does that make sense? So this is a radius r. This perpendicular segment is the same length as the radius. And then picture that just bending over until it touches the circle there and lays on top of the circle there, like right there. So now I'm going to get rid of this here just to show you that that's what I did. Now this length here, even though it's curved, if I straightened it, it'd be the same length as this radius, okay? Now what I'm going to do is I'm going to take another segment and I'm going to draw a line segment over to here. So now I have another radius, length r. So this is a length of r, this is a length of r, and this is a length of r. Well, guess what this angle measure is right here? It is 1 radian. Okay, that is 1 radian. Well, you probably still are wondering, well, what in the world is a radian? Now I want to focus on, let me get my trash can out of the way over here, all my garbage. Okay, so if this is 1 radian, remember that if you have a right angle, like so, it's 90 degrees. Okay, so this is 90 degrees. If you have a straight line, this is 180 degrees. And then if I draw a ray and this full rotate, this angle all the way around one time is 360 degrees. So this full rotation is 360 degrees. Okay, so let's get that out of the way. So we all know that circles, a complete rotation of a circle is 360 degrees. Okay, and if you keep in mind that, let's see. All right, so from here, what we want to know is how far around that is. So I've already told you that it is 300, where's my pen? 360 degrees is a full rotation of a circle. Okay, so now if we're going to talk about, well, what is this all the way around in degrees, then we say circumference. So circumference equals 2 pi r. Okay, and what the circumference means is, okay, well, how many of these arcs would I need to get all the way around one time to equal 360 degrees? So now I'm just going to say number of arcs equals 2 pi times the radius. Okay, but pi is 3.14, an approximation. So 2 times 3.14 is 6.28. So what that means is if I took this arc right here, and copied it and pasted it, 1, 2, copy, 1, 2, 3, 4, 5, 6, and rotated it and put it on this circle, which I'm going to do in a moment. Let me do it behind the scenes. Okay, so as you can see here, I have 1 radian, 1 arc, I should say, 2, 3, 4, 5, 6, and then there's that tiny little piece right here. That is 28% of another arc, or 0.28, 28/100ths of an arc. So it took 6 and then just a little bit more to equal the number of arcs to make 2 pi, which is a full rotation of a circle. Okay, so with that said, then we're going to say that the number of arcs equals 2 pi, and then 1 full rotation equals 2 pi radians. Because 2 pi is 6.28 roughly, and that's 1 radian, so it's 2 pi radians. All right, now with that being said, keep in mind that a full rotation in degrees is equal to 360 degrees. So both 1 full rotation is 2 pi radians and 360 degrees. Since they're both equal to 1 full rotation, they're equal to each other. So now I can say 360 degrees equals 2 pi radians. Okay, so now what we're leading up to is a quick conversion to go from degrees to radians. So if 360 degrees equals 2 pi radians, well, what did 1 pi be? I want to divide this by, I want to divide both sides by 2. Okay, so let me get rid of that. So if I divide both sides by 2, then the 2's cancel and I get 180 degrees equals 1 pi radian. Okay, so that would be a straight line, which is 180 degrees. So a straight line has pi radians. Okay, so well, what is 1 radian? Well, if I just want to solve this for radian, I just divide both sides by pi. And when I do that, the pi's cancel, and therefore 1 radian equals 180 degrees divided by pi. Okay. So getting back to this 6.28 thing, well, let's just hang on 1 second. Okay, so if I take that 180 divided by pi, well, what's 180 divided by 3.14? 180 divided by, and I'll just use the term pi, and I hit enter, and so I get 1 radian equals approximately, let me use an approximate symbol, 57 point, and what was that? 57.3 degrees approximately. Okay, so this angle measure here is 57.3 degrees if that was 1 radian. Okay, hopefully that makes sense to you. And that is 1 radian conversion. 180 degrees over pi equals 1 radian. Okay, so moving on to a definition, sector. Okay, a sector. What is a sector? Let arc AB, which is right here, right there, be an arc on a circle with a center of O and a radius of R. So there's R. The union of all segments OP, where P is any point of the sector, or the arc AB is called a sector. In other words, if P were right at A, then OP is OA. And then if I move P to here, all this is really fine little lines going. What they're basically saying is every single line segment in between O and, or a segment that goes from O to the edge of the circle that we call P, every point P between and including the endpoints A and B form a sector. Think of a piece of or a whole pizza, and you cut 1 slice out of it. The slice of pizza is a sector. Okay, and continuing on to exercise 1. Let me move this over. Center it a little better. Exercise 1. It says the radius of the following circle is 36 centimeters. So there is no radius drawn here, but if I were to draw a radius from here up to A, or here to C, or here to B even, the length is 36 centimeters. So there is one given. So R equals 36 centimeters. The measure of angle ABC is 60 degrees. That's labeled right there. What is the arc length of AC? So we've been doing arc measures, and that's the difference between a measure and a length. So arc measure, so if it said what is the measure of arc AC, it would look like this. The measure of arc AC equals, and we would, since this is an inscribed angle, then the arc is twice the arc angle. So the angle is half the intercepted arc. The measure of arc AC would be 120 degrees, but that is not what this question is asking. What is the arc length? Okay, so we would say arc length equals, and what the key to this problem is we want to draw a central angle. We want to know what the central angle is. So I will draw it from A up to, or from the center up to A, and from the center over to C. So this angle measure right here is a central angle, and this was 120 degrees. So this central angle is 120 degrees. So really, once you get the hang of this, you realize that if you have an inscribed angle, the central angle will be twice that, provided that the endpoints of the arc are the same endpoints. Okay, so they intercept the same arc, then the central angle is twice the inscribed angle. So what is the definition of our arc length? This is new, so let's go back up. It is 2 pi r over 360, or it is the central angle. I like to write it like this. I like to write the formula first, theta over 360 times 2 pi r. That is arc length. And then I'll, instead of writing arc length every time, I'll just put equals. Substitute my givens, 120 divided by 360 times 2 pi, radius of 36. The zeros cancel. 12 divided by 12 will go into 36 3 times. So that reduces to 1/3 times 36 times 2 is 72 pi. And 3 will go into 72 evenly. So 3 goes into 7 twice with a remainder of 1. And 3 goes into 12 6 times. So the arc length is 26 pi centimeters. Now it did not say what is the approximate length. It says what is the arc length. So stop there. But if it did, then you could just go in here to your calculator and say 26 pi and hit enter. It'd just be 3.14 times 26. So that would be approximately 81.68 centimeters. We're okay with just 26 pi centimeters for our representation. Okay. So that is the arc length. Let me just move this up a little so we can read the next problem. Okay, so now it says, what is the radian measure of the central angle? Okay, well, what was our formula for radians? So you might want to write that every single time. A radian equals, okay, made a mistake on the last problem. So let's fix that real quick here. I did everything correct except set 3 goes into 7 2 times with a remainder of 1. 3 goes into 12 4 times, not 6 times. I don't know what I was thinking. But anyway, it's 24 pi centimeters squared. So therefore, when I go to my calculator, it would be 24 pi. My apologies for that. And that would not be 81.68 centimeters. It'd be 75.4 roughly. Okay, so carrying on to this, a radian. Okay, a radian. What is the radian measure of the central angle? So arc length, let's do it this way before I just write radians. Arc length is the angle measure of the central angle in radians times the radius. Okay, so arc length equals the central angle in radians times the radius. So the arc length is going to equal angle measure of the central angle in radians. Okay. And then I'm just going to substitute in my given. So it's going to be all of this again, repeated, times the radians, times the radius, which was 36. So I'm just going to say 36 here. So arc length equals the angle measure of the central angle in radians, and here it is, 24 pi. Okay, that's the length of the central, measure of the central angle in radians. So that would be 24, and the arc length was 24 pi, so that goes over here. So arc length, 24 pi, equals angle measure of the central angle in radians, which we're trying to find. Let's just call that x for now, times the radius, 36. So how do I get x by itself? Divide both sides by 36. So the angle measure of the central angle in radians is, so then I'd say x equals 24 pi over 36. And that reduces, because they're both even, 12 pi over 18. And 3 will go into both of those, so that'd be pi over, actually 6 will go into both, 2 times and 3 times. So it's 2 pi over 3 radians. Okay, so 120 degrees equals 2 pi radians. Now remember what I said before, if you have an angle measure 120 degrees and you multiply it by, think of that as over 1, and you multiply it by pi divided by 180, okay, watch what's going to happen. These zeros cancel, and 6 will go into 12 2 times, and 6 will go into 18 3 times, and we get the same 2 pi over 3. So either way you do it, it comes out the same. You can set it up this way. Arc length equals x times the radius, and then divide both sides by the radius. Or you can just simply take and multiply the degree measure of the central angle, multiply it by pi over 180, and reduce. Either way, you'll get the same answer. And of course, these are radians. Okay, page 3, example 2. Circle O has a radius of 10 centimeters. So there is our first radius of 10 centimeters. What is the area of the circle? Write the formula. Okay. All right, so here we go. Write the formula. Area of a circle equals pi times the radius squared. Substitute in the given. Area equals pi times the radius squared. So therefore the area equals 100 pi centimeters squared. Okay, should be writing centimeters on every step, but as long as I have it in the answer, I guess. So the area is 100 pi centimeters squared. What is the area of half of the circle? Write a formula and explain. So you would say the area of a half circle or a semicircle would be area equals 1/2 pi r squared, which would be 1/2 pi times that same radius of 10 squared. So area equals 1/2 times 10 squared, which is 100 pi. And that would simplify to the area equals 50 pi centimeters squared. Okay, so it said, and explain the formula. So this is the area of the circle, 50 pi centimeters squared. That's the area of the half circle where the radius was 10. And think of a half a circle as 180 divided by 360, half a rotation. So you go halfway around a circle, that is only 180 degrees. You go all the way around, it's a full 360. So it's 180 divided by 360, and 180 divided by 360 is a half. Okay, part C says, what is the area of a quarter circle? Write and explain your formula. So you'd say area equals 1/4 pi r squared. So substitute in our givens, 1/4 pi with a radius of 10 squared. So the area is going to equal 1/4 times that same 100 pi centimeters squared, and 1/4 of 100 is 25 over, not over anything, it is 25 centimeters squared. So think of it as 90 over 360 is 1/4. I suppose I should have written this up here. 1/2 equals 180 over 360. 1/4 equals 90 over 360. So 1/4 of that circle is 25 centimeters squared with a radius of 10. D says, make a conjecture about how to determine the area of a sector defined by an arc measuring 60 degrees. So what you would say is, so these are all sectors, right? As we get smaller and smaller, a sector is like a piece of pizza. You can cut a pizza in half, cut a quarter pizza and make 4 slices. We could cut it again and make 8. We could cut it into different degree measures. If we're going to do a 60-degree angle, then we would say area of the sector. Let me see, does it give a name of a circle? Make a conjecture about how to determine the area of the sector defined by an arc measuring 60 degrees. So that would be the area of the sector would be area equals, and 140 or 1/4 was 90 over 360. 1/2 was 180 over 360. So 60 degrees would be 60 out of 360 pi r squared. So then area equals 60 divided by 360 reduces down to 1/6. 6 goes into 36 6 times. It'd be 1/6 pi 10 squared. So that would equal 1/6 times 100 pi centimeters squared. Okay. And if I simplify that, then 100 would turn into 50 pi, and that 6 would reduce to 3. Half of 100 is 50, half of 6 is 3. So we get 50 pi over 3 centimeters squared, and it does not reduce any further. Okay. So the area of that sector would be 50 pi over 3 centimeters squared. Okay, circle O, part E, circle O has a minor arc AB, with an angle measure of 60 degrees. The sector AOB has an area of 24 pi. What is the radius of the circle? Okay, so this is where it really becomes important for you to write formulas every time you ask a question's asked and you substitute in the givens. So I'm going to write area equals pi r squared. That's an area of a circle. The area of a circle, but then when we have a central angle and we want the area of a sector, then that's going to be the central angle divided by 360 times pi r squared. And we don't know the radius this time. We know the area. So now I'm going to plug this in for area. So I'm going to do that over here. So that would be 24 pi, that's my area, equals 60 over 360 pi r squared. Okay, well, if I divide both sides by, if there's pi on both sides, they cancel. 60 divided by 360 reduces to 1/6. So this gives me 24 equals 1/6 r squared. Multiply both sides by 6 to get rid of that 1/6. And I get 6 times 24, 144 equals the radius squared. And then I take the square root of both sides, and we have found our radius, r equals 12. Let me write that better. R equals 12 centimeters. Okay, actually it didn't say centimeters. I was thinking of the last problem. So when it doesn't say centimeters, what do we say? Units. Okay, so that would be 24 units. Okay. F says give a general formula for the area of a sector defined by an arc of an angle measure of x degrees on a circle of radius r. So area of a sector, which is what we've been doing on this page, area of a sector equals the arc measure or the central angle measure divided by 360 times pi r squared. Okay. Okay, what page are we on? I lost track. Page 4, exercises 2 and 3. Pause the video, see if you can do these, come back and see how you did. So it says here the area of sector AOB, sector AOB. It's this slice of pizza, if you will. The area in the following image is 28 pi centimeters squared. So they gave us the area, and it says to find the measure of the central angle x. Okay. All right. So area of a sector equals theta over 360 times pi r squared. So therefore the area of the sector we're given 28 centimeters, 28 pi centimeters squared equals x over 360, don't know theta, we're trying to find it, times pi, and the radius is 12. So there's the radius there. They didn't tell us in here, but they told us in the diagram. So that's times 12 squared. So substitute simplifying now, 28 pi cm squared equals, and this would be cm here, by the way, x over 360 times 144 pi centimeters. The pi's cancel. And then we can do it a couple of ways here. I could actually, this is 144. We could rewrite this as 144 over 360 times x. Because if this is over 1, we can just flip the tops here and do this. And then multiply by the reciprocal, 360 over 144. Or we can simplify that and say, well, what's 144 divided by 360? And that is 0.4. So 2 to 5. Okay. So this reduces to 2/5. Okay. So we have 2/5 x times, or x times 2/5. Okay, so this all cancel now, and it's the same as 2/5 x. So let me just clean this up here. So I reduced x over 360 times 144 down to 2/5 x. So obviously to solve for this, we just want to multiply by the reciprocal 5/2. 5's will cancel, 2's will cancel, and we get x to equal, and we multiply this side by 5/2. Well, 28 divided by 2 is 14. 14 times 5 is 70. So x equals 70 degrees. All right, number 3, in the following figure of circle O, the measure of angle AOC is 108 degrees. There's a given. That's our central angle of arc AC. And the measure of arc AB equals the measure of arc AC, which is 10 centimeters. Okay, actually I shouldn't say the measure. The length of arc AB equals the length of arc EC, which is 10 centimeters. So arc AB equals AC equals 10 centimeters. Well, why does this say 15.08 in the diagram? Okay, so let's just disregard this for now and these being different. I think that's just a misprint. Find the measure of angle OAB is, let me draw that and let me explain how to do this. So that we're looking for this angle right there. That's the angle we want to find, this measure right here. Okay, well, this is 108 degrees. So regardless of this being 15.08, if this was 10, like they said in this over here, not 15.8, and this one is 10, all they're trying to tell us is that they're equal. So this is a central angle. So if this arc is 10 centimeters and this is 108 degrees, then this is 108 degrees because this is 10 centimeters. So this is 108 degrees. So 108 plus 108 plus the measure of angle BOC equals 360 degrees. Okay. All right. So this would be 216 plus the measure of angle BOC equals 360 degrees. So therefore, the measure of angle BOC equals 360 minus 216, which is 44 degrees, 144 degrees. Okay, so this angle here is 144 degrees. And therefore, the measure of arc BC is going to be equal to it. That will also be 144 degrees. Okay, so how do I find this here? Okay, well, this is 108 degrees. This is a radius right here, and this is a radius. So therefore, that is an isosceles triangle. So this angle here, angle ABO, is congruent to angle BOA, and this vertex angle is 108 degrees. So we would say x plus 108 equals 180 degrees. The triangle sum theorem. And actually, I might as well just write that over here because I'm answering A right now. And then combine like terms, 2x plus 108 equals 180. And then subtract the 2x, or I'm sorry, subtract 108 over from the other side. 80 minus 8 is 72. And then divide by 2, and x equals 36 degrees. So there's the answer to A. All we had to do is realize radius is radii and equal measures of central angles because of equal lengths of arcs. And now B says find the measure of arc BC, and I've already done that down here. And so that is 144 degrees because an intercepted arc is equal to the central angle that intercepts it. And now it says find the area of sector BOC. So sector BOC, now let me erase all of this that I don't need. Let me erase what I don't need. I don't need this up here anymore. And now we're talking about sector BOC, which is right here. Okay, so that's 144 degrees. This is 144 degrees. So remember what the area of a sector is. The area of a sector equals 144, the central angle, divided by 360 degrees times pi r squared. So the area is going to equal 144 divided by 360, 144 divide 360 equals 0.4 as a decimal, 2/5 as a fraction. That reduces down to 2/5 pi, and the radius was 0.4 Let's see, did it give the radius? Okay, so they did not give us the radius. I'm chuckling here because I paused the video and I calculated it with the given information. So what we have to do is say, okay, well, this is 10 and this is 10. So that's 20. And then we have an unknown distance right here, don't we? So if I say that our circumference is, how did I do this? 216. So if this is 108 degrees and this is 108 degrees, that's a total of 216 degrees representing these arc lengths up here of 10 centimeters. So I took that 108 plus 108 and I said 216 over a full circle. So this portion of this circle divided by the whole thing is equal to this portion of the circle, which is 10 plus 10 or 20 divided by the whole thing, which we don't know. So I cross multiplied and I got 216 equals 7,200. And then I divided, 216x cross multiplying. 216 times x is 216x. This times this equals this times this. That's where this came from. And then finally, I divide 216 both sides. And that gave me x. Okay, what is x? Well, x is going to be our total circumference. Okay, so when I did that, I put that in the calculator, 7,200 divided by 216. And I got 33 1/3. This is my radius. I'm sorry, not my radius, my circumference. That is circumference. If this is 10 and this is 10, that's 20. The whole thing is 33 1/3. In other words, this is 13 1/3 down here. 20 plus 13 1/3 is 33 1/3. Okay, so I found the circumference. Circumference equals 2 pi r. So circumference is 33 1/3. That's equal to 2 pi r. Divide both sides by 2 pi and we will find our radius. All right, I'm chuckling because I'm amazed that they gave us a problem like this in a new concept. So I take that 33 1/3 right there and I just hit divide now. It'll say answer divided by. Don't make this mistake. If you just say 2 pi here, it'll divide by 2 and then multiply by pi and give you a bigger value. You want to divide by the quantity, the whole thing in the denominator of 2 pi in parentheses. So 33 1/3 divided by 2 pi equals 5.31. So my radius is approximately 5.3. And it's 05. If I round that, it's 5.30516. Let's just leave it with 05. Okay, so there is my radius, 5.305. That goes right here, times 5 point, whoops, not per decimal. Let me just use a parentheses now for my radius. 5.305 squared. Holy cow. Okay, so then we get 5.305 squared. So now I'm not gonna round this because I want to be as accurate as possible. So now I just hit squared and hit enter, and that'll give me 28.145. So it'd be 2/5 pi 28.145. And now let's just finish this. So 28. Now I'm going to multiply that by times 2/5 pi and get a decimal. And we get 35.37. So this is 35.37. It's area, it's centimeters squared. Woo! Did you follow that one? Okay, there we go. Okay, page 5 brings us to the end of lesson 9. Review the lesson summary, relevant vocabulary, review your new formulas, arc length, sector area. and go do your problem set.